within our OMiLAB laboratory setup. Okay? So I'm very happy that we can do that here. Everything that we see here around, so we have a few tables, a little bit of presentation, we remove the chairs and we would like to create a working atmosphere. So we're not sitting down and looking at emails, but we are doing things live now. That has always a bit of a challenge, right? It can go wrong, but there can be problems. But we don't worry about that, since this should be a space that allows us to prototype, that allows us to innovate, and we don't want to follow like productive ready systems. So the people market will not like that, but we play around with things. Okay? So what is the objective here? Is we have the OMiLAB setup in a similar stage all around our network. So what we have built up here is the we call it starter package of such an OMiLAB. The OMiLAB consists of 3 spaces. An OMiLAB consists of an innovation space, because we use that for design thinking. That's what you see here on these 2 tables. We will see for demonstration what we believe what is the added value over here. You have another table that belongs to that one that has a lot of paper figures on the left. This is actually our work material. Right? So we will show you how we can create, using paper elements, how we can create a scenario, an innovative, novel, disruptive business case, business ecosystem, considering all the aspects that we would like to look into. We use here an approach that is stemming from a software company that provides that as open source. The software company is called SAP. I'm not sure if you heard about SAP. It's a small company, right? Very German, right? It's still German, I believe. And the interesting thing is we're not talking about ERPs or something, but they have developed something that they call scenes, S-C-E-N-E, with an S at the end, so it's plural. And they use that for storyboarding. And the idea here is we can use these elements to discuss. So coming from different backgrounds, I think we have somebody from healthcare, we have somebody from production, we have somebody from industry, maybe also within the organization. So you have somebody who's a legal expert, a production manager, or whoever, whatever role that is. What do we require in order to talk to each other? We require a common level of abstraction. So we need to find elements that we agree what they mean. And this is what we utilize here. We use this paper figure so that we can very quickly and efficiently talk about those things. At the end, I believe all of you have heard about design thinking before. You can play Legos, or you can put posters on the wall. That's all great. We have done something that we will show you later on, that we can create from the design artifacts, we can create a digital twin. Okay, so we can use that in order to digitalize whatever we see here on the paper that we will produce collaboratively now. We can transform that one into a model-based representation. So we come back to our modeling idea. We think that we need models that we can then produce further formalizations and further operations on top. That takes me to the next space. We have done experimental settings. So we see, I'm pointing in the wrong direction, over here with the robotic arm, one setup, and another one with an autonomous driving car. And the question, and that's something you have to reflect upon, how do we get from a very high scenario definition to the feasibility study that we would like to do on this robotic device? And of course, for the scientific people, there's a huge semantic gap in between, because we have abstract representations, and we would like to make it run, right? And we don't want to make it run in a virtual setting. That's one option, of course, because if we have a demonstrator, a simulator that shows us that things would work, that's great. But we would like to do it also on a physical level. So we have actually physical devices that we can play around with. And for us, this gap that we have in between, we bridge those with conceptual models. So we use models to describe things. Can you explain what conceptual models are? Or I'm not sure if that is well established, but something like processes, rules, enterprise architectures, things that we can think about that formulate the things in a language that has an execution semantics that allow us to run those kind of things as well. Okay? So this is our core challenge. We're just showing that one on the slide over here. So what is our objective? Our objective is that we have a table on the left-hand side, that's the haptic design thinking, and SAP is one instance of that one. The SAP Scenes approach is one instance of that one. You can also use post-its, of course. But we would like to understand what is our new idea that we would like to work upon. We do a decomposition and a digitalization. That's what you recognize here on the right. And the tool is an open source tool that we use here that's called Scene to Model. I will show that to you later. On the other hand, we assume that we have a cyber-physical environment, whatever it is, depending of course on the domain. So you have robots, you have sensors, actuators, whatever it might be. And we do another step here, and we call that one abstraction. So we use that one in order to create what we know as a digital twin of this physical space. And then the question is what I mentioned before, how do we make sure that these two things meet here in between? And we can fill this gap with any kind of modeling technique that might be applicable. Okay? Let's do a quick demonstration, Julia, and then I think we open the floor for discussion. And I would also ask you to get involved when we do this kind of scenario building. For the technical parts, maybe we need more time and we don't have too much time. But I just want to demonstrate that one to you. Okay? Julia, can we walk through a scenario?
Yes, let's do it.
We do a generic scenario first,
yes.
I would propose. Okay? So imagine stakeholders from different backgrounds come together, they meet in a workshop room like that. And now they start to discuss a scenario. I give you a generic one, and then we have a look whether we can also do domain-specific scenarios and what that means. I give you a scenario that I would like to demonstrate to you. Let's assume I want to do grocery shopping. Who likes to do grocery shopping?
Well,
Who likes? Who likes to do it?
must.
You must do it, you're right. But do you like to do it? I don't. I don't want to go to the supermarket. That's a boring thing, right? I mean,
No, I like it.
yeah. I like it on Saturday mornings when I can drink a glass of wine. That's perfect. But like for the regular thing, family business, you want to go shopping. Maybe you would like to surprise your wife with a nice dinner in the evening. Well, that is something that is tricky, right? So let's assume we have the following situation. Let's assume that this is me, with a lot of hair still. Right? I'm over here, and my wife is over here. Let's do the other way around. My wife is in the office, I'm at home, so to make it a bit more gender specific. Right, and what I want to show now is I want to show what is my challenge, my actual, what I would like to come up with. So I have a challenge, or my wife has a challenge, not me. She is in the office, where do we have an office over here? And I tell you the story that she has in mind. So she wants to surprise me with a nice dinner, and we would like to show that one graphically. So we have two different spaces. The backgrounds represent what is going on. We have the lady over here who is struggling to do something, and on the other hand, that's me, and I'm hungry. I would like to eat in the evening. And I can now utilize this information. You see it on the screen in the back. Julia, maybe we can run the first import on things. Let's hope that we get everything. So that's a bit depending on light conditions, but that should be fine. And what we retrieve now is, here we go. We get everything, yeah, everything is here. A bit further, a bit long distance in between, but what we can recognize, we get the elements that we put on the white panel right into our tool. And this is a modeling tool already. So it's seen to model, the model stands for the model itself. So what we see here is not just a photo that you take with your mobile phone. You can do that, of course, but what does that require? You need to describe it. You can write something down, etc., etc. Here we have a model with objects, so maybe be perfect. We have attributes, properties that further describe what these elements mean. When we talk about models, well, we need to be more precise. I believe this is not a conceptual model per se, it's a diagrammatic representation of whatever is on the part over here. If you would like to understand the technology behind, we are doing it very trivial. We have here something that are QR codes. I think everybody knows since Corona what QR codes are. We have a knowledge base in the background that actually reasons about those things and then represents the objects and has the types ready for us. This is great. So the challenge is described, and now let's see what we can do. Is that we replace the challenge. I remove myself as well with a way of interaction. Here we go. Interaction. Everything happens in the app now, right? So we say, well, there's an app for everything. And I would like to do smart grocery shopping. And smart grocery shopping means that we send off the order, whatever the lady would like to shop. We send it off via an app. The app is super smart. The app knows my Instagram profiles, knows my food pictures that I put online, and I don't need to write things down, but I'm just saying, get me something nice to eat. So I'm doing it very high level, and this is sent over. So that one that has information moving on into a smart warehouse. The smart warehouse has, of course, a robotic arm, produces a package of my needs that I have. And maybe we can get that as a second scene of our story for into the system. All right, here we go. So we see that we have this transformation already happening. We have the mobile phone in there. The mobile phone sends things over to the robotic arm. The robotic arm digests my information. Maybe it's also smart in the sense that it takes care about my nutrition, health status that I have at this point, and then actually puts the package together. So we could enrich that one, and this is then what we're using here is standard figures in a sense. And for the CoDEMO project, we have already built some custom figures, so let's simply we update this one. Just wait a second, because I think we need to be more health related. And so we have healthcare here as a concept as well. So the mobile phone also retrieves my. You have to help me. What do we retrieve?
What do you need to eat? Like what vitamins or something?
Vitamins I need, etc. Correct. So I can put that as an additional object in there, and we should get then the view added to that one as well. It gets, of course, more interesting if you start to challenge me. So assume we do such a design thinking workshop, not like me explaining you a story, but we have a different expert in here. So if I would nominate Michael now to be our legal expert, he will start to shout at me and say, well, we need to make sure that in here we have a legal issue because we need to make sure that the data is protected and security is around. So we would need to extend the scene, or we need to decompose it into a different image. If we have somebody from production, where are the people from production industry? They're hiding. Oh, sorry, over here. Right, so you will tell me, well, we need to look into how this robotic arm is actually finding things, and what are the parameters that this system requires. So we can look at it also from the technology point of view, from the production point of view, and we will update and modify the scenes accordingly. Right. This is a mechanism that we can use in order to externalize the knowledge in a collaborative, co-creative setting about a specific scenario that we have. What we would do further on is, we would further extend these representations with annotation techniques. What does annotation mean? We describe things further, and we would add then elements to the representation. Maybe you can add
to the first scene.
Oh, let's go for the second one. You added something, all right.
Text here.
Perfect.
Or also for the second, we can add text to the phone.
But textual annotation is one option that we have, correct? That's a good thing. Leave it like that. That's a way.
No,
right.
You're also using
We can
ML
also-
languages to maybe develop from that point, from initial scenarios to learn and not to go back all the time.
Correct. We can learn upon what we have done before, but it's actually a human thing. So it's a human interaction. Yeah, but we could imagine.
You do it once on the human level, but then if you want to reproduce it, it can be learned.
You can use the model then for future processes. We can also annotate things with additional concepts. Maybe we can show that one, that we have at the production part, that we have here a process that is happening. So we have this packaging process. So we assume that we have a lot size 1 production logic, right? So we have the customer sends an offer and the package is produced. And we have then additional concepts that we can add in the model, in our digital twin. So well, we have here the packaging process that takes place. And that would be an indication for us, well, we need to look further into detail how that actually happens and how it works. Great. If you would like to try another one, we can say, well, how does that fit? I'm trying to combine domains, that doesn't make too much sense, but we can also think about how does the sourcing work. So if I remove our demand part on the left-hand side, and I'm trying to put in here, so how does the robotic arm find the right things so that this guy can produce the packages? So maybe we need to have something like, sorry, we have something from the crops, right? So we have agriculture, where are the people from Valencia? Right over here. So maybe we have something over here and say, well, we need to find a way that these things that are on the fields, the crops, are processed, transformed, and then moved into the warehouse.
Yeah, they need to be somehow connected, maybe,
Right,
right? Like
right,
to,
correct. Mhm.
to collaborate with each other.
Right, so that we have a supply chain that is coordinated, and do we have transportation somewhere?
A drone.
So let's take this one, and the drone transports then our crops into the warehouse. Wait, 1 second, we need an error. Please give me this one. So we can represent that there's some kind of interaction happening from the agriculture perspective. So, of course, that's very superficial. We would need to go further into detail, and this process of detailing it is called decomposition. So we can describe things either sequentially, following each other, or we actually break it further down and move it to a level of decomposition that is then appropriate, that we can then work upon based on our expertise in conceptual. Okay.
There are legal issues too.
Legal issues. Then we have
Yeah,
legal issues.
because of the food security.
Legal issues, obviously. And I think you need network, right?
Having a
You need
decomposition,
a
no
strong
legal issues.
network on the field.
Having a decomposition, I don't have any legal issues because
And
it's
the
not gonna
transportation.
define language.
Yep.
I don't know if the drone would be so hygienic, you know.
That could be an option. What would be an alternative? What would you recommend instead of a drone? A drone is good, right? It can go anywhere. It doesn't
Yeah,
have
but you
streets.
need to hygienic the
Oh,
the
cleaning
arms, I
things.
don't
Okay.
know.
Let's mark
I
that.
don't know
Okay,
that.
we have this one properly done.
and a robotic arm too.
In a small.
Cleaning, water. Water is important, right? I'm just putting concepts in here. Maybe they don't make sense now, but we can describe what you just mentioned, maybe like that. What is important to consider here is what we use here. We use a domain-specific representation, and this is what this scene-to model tool is capable of. That we can dynamically adapt to the domain that is in focus. So currently, when you look at that one, we try to find some nice representations that fit to the domains of CoDEMO. So we have a few icons for production, for industry, a few icons for healthcare. So this goes into the healthcare domain, but of course this is random. That's something that we just came up with. And I think one of the learnings that we need to provide also during our trainings, and how do we identify the appropriate representations that a domain expert would require. So when you think about your experts in your organizations, how would these people start to work with each other, and what kind of representation is then needed in there? Good. Further questions? I'm talking too much. I'm too excited. Right. What I would propose is that we move on. Julia, can we move back to our warehouse model that we have done before, the packaging part, the previous one?
One question, can you also, beside the scene to model, do you also have object to model?
Not yet, but this would be a great idea, yeah. Yeah.
So, yeah.
I mean, technically, the system is flexible in the sense that we have two ways of recognition. We can do it through QR tags, and there's a novel way that we don't have here in the lab yet, since that is still in development, that works through image recognition.
So
Recognition in
then you
general.
would have only like this.
We'd only have this one, and you would recognize
So
them.
it's also possible?
Yep.
Okay, great.
Of course, that requires then additional effort in the preparation, because you would need to train a neural network to understand what is and how this interpretation should happen. But technically, it would work.
We do have already.
Perfect. Perfect. And you can see how we can combine these pieces together. What I would like to show you now, if you just quickly turn around, how do we get, now we are on the top right side of this digital twin of haptic design thinking environment. So our scene to model represents this one. We have a model over here. And on the other hand, we have physical devices. So what I would like to showcase to you is our case that we have here for our warehouse with the robotic arm. Can we test things out, and can we evaluate whether this would work in a, let's say, in a playground warehouse, in a laboratory setting warehouse? Okay? And this is what we can recognize over here. So it's a bit messy from back and forth, but what we see here, this would be our warehouse robot. Okay? It's of course not an industry-grade robot, as you know from your production lines. It is something that we have that you can get online. It's called Dobot, and it's a STEM educational element that we can use it for. The good thing is we don't need to worry about security and safety issues. Nobody will be harmed because it's small enough. But the core idea is, well, if we use that one, what are the capabilities of such a robotic device? You can ask the same question for our car over here. But what are the capabilities that we have on such a device. And well, this thing does quite a lot, and it is from a pricing point of view not expensive, so we can play around, we can modify it as well. I will use for our first part, namely for that one, I will show you how that works with the robotic arm. So our warehouse is already stuffed. So we have the good part is that this incoming logistic has happened already. So we have a lot of things here. We have sweets, we have pretzels, we have meat and sausages, and we have fish, etc. And for our demonstration here, we assume that the positions are known. So the warehouse is not a chaotic Amazon warehouse, but it's a warehouse that has well-established slots where things are positioned. And the question is now, well, if I have the input, you recognize we're ordering food is the input. We don't know fish or meat or whatever it should be on the list, but we just say we want to get something, and we would like to have the logic implemented how we can create our package. And this is something that we cover with a conceptual model, and we use here as an example for that one, we use here flowcharts. Everybody knows flowcharts, right? Simple technique to show the steps, the sequences that are there. The important thing is that we actually have abstracted what are the capabilities of this arm. And if you think about a robotic arm, what can this arm do? It can move to an XYZ position in a three-dimensional space, with limitations, of course, because of the size. For this configuration, it can turn on this suction cup, so it can lift things up. You have that on in the back. That's like the vacuum cleaner that creates the vacuum. And then it can drop things off, so we can turn it off again. And there's one operation that actually calibrates the whole thing, but that's more or less it. There's nothing else. And these four capabilities, there's an API on that one, so we have a small processing unit, the Raspberry Pi, that is responsible to process the requests that come in, and then the robotic arm can do whatever is required. Now, in order to do that one, typically we would say, well, we need to sit down, we need to write C code, Java code, Python code is the new thing, right? And then we have the implementation of this blue box over here. This is one option. What we would like to try is whether we can make it through a model interpretation. So what I would like to show you here, I know it's a bit small, but we can rerun the whole thing. So we have represented how the processing logic should be in a flowchart. So the flowchart says, well, in the first step, ask the user what should be put into your package. And the question is not about exact ingredients, but it is about preference. I would like to have something healthy, something standard, something that is related to snacks, or something extravagant. And based on that one, a sequence is executed and the package is produced. So somebody has sat down before and said, well, extravagant means something to us. And what I can do now is I can start this execution, and we trigger the interfaces that are available on the robotic arm through the model-based representation. So that means, now the first step, that's the calibration step. That's an important one, because we would like to know where 0, 0, 0 is. Perfect, we are there. We should get a short beep over here. Coming the way to Mika. Good. Now we have a small pop-up that says, what do you want? What do you want, guys? Healthy? Sweets. Sweets. No sweets here. You can do snacks if you like. Let's run through the snacks part. And snacks is defined now as a sequence of pick-up, drop-off parts that we see.
So we're getting sweets. Those are sweets.
Right, snacks is sweets. I have an answer for everything. And we put the pieces together. The interesting thing is, like Mr. Süße said, I want to have sweets only. Well, what does that mean? We don't need to touch source code or anything, but we would need to change the model over here. And everybody can change the model, since flowcharts are a super trivial way to model, right? So we would say, I would like to have only sweets, I have another branch in there, and I would be ready. But we can further innovate, we can further think, and so, well, this is interesting, but I was expecting from you, as I said, well, what happens if sweets are empty, right? So currently, what would happen is, our implementation here is the sweet spot here doesn't have anything on stock, so I cannot pick anything up. The logic in here will just try to pick something up, so it will not work. So we would need to extend and say, what is our mitigation action that we would like to implement on model level in case something's missing? Or let's assume we have an Amazon-like warehouse where everything is anywhere, and we just throw the cards in. But I would need to have I need an additional capability down here that I monitor what is in the warehouse and I can get this information from. Or if something's empty, what could be a mitigation strategy? Well, I need to call the farmer to get additional stock into it. And I could actually demonstrate this one as well. Right. One case.
The connection between that scene and this scene.
The connection is the
through
blue
your
box
servers, or-
over here. The blue box, and then what we do is we actually decompose this blue box further. So we make it, we describe this blue box in the form of a flowchart. Of course, we can build that on patterns. This is what we actually do. We have different patterns that we can combine. This technical abstraction of flows that we have in there. But of course, that happens, as my German colleagues would say, in between your ears. So you need to think how you would like to realize that.
Composition is not automatical, it's manually done.
It's a manual, and it's an intellectual
Innovation
exercise.
thinking, yes.
Correct.
What I can imagine, in case we will use the laboratory to support innovation process with companies, there is a temporal separation a bit between these experimentations
Correct.
and these experimentations.
Mhm.
The link, intellectual link and technical link exist, but certainly you need time to
Correct.
prepare the demonstration of the process.
Correct. Correct. We cannot do that right away. We cannot
Yeah.
derive it directly. We can think that we prepare skeletons. So an example is when we look at the scene, and maybe you have something in mind like a process like a BPMN. In BPMN you have actors, and we can say about every person, every lady and every gentleman that we find in here becomes an actor. Every error becomes a relation. So we can transform, since we have over here, we have already a model-based representation, we can do a model-to-model transformation, and then create that as an input in order to support that one.
But another idea, perhaps, of the project within the 3 years is just to try and experiment some utilizations of these environments, and if it's pertinent for you to bring some advices or of needs of improving the infrastructure, the technology, well, I think it could be a good way to work with the OMiLAB also to change a bit and to
Should
bring
evolve.
even more mature tools.
So you're doing digital twin over there, also digital twin
Correct.
for the flowchart.
Correct.
How do you ensure the cybersecurity of it? A
We
digital
don't
twin?
care. We're in a lab setting. Hard, we don't care. Because we have
Yeah,
a-
somehow in future we
I agree, I
innovate
agree.
and we develop to put
I
it
agree.
in.
I agree. I think this is something that I think we should look into that one from within the scenes first. Like which aspects within our ecosystem require security? You're perfectly right. For the execution, for the implementation, I think this is a transformation step. So that would mean I would need to transform that one on a level where we have then all the security issues, all the redundancies, and then safety things actually covered.
Because, sorry, you are finished?
No, go ahead.
Because the things are prototypes, in fact, small prototypes. Prototypes of
Digital twins of design.
yes, of scenes, that means of process, etc., and prototypes of small technical parts of the process. So it's not dedicated really to the real life, but to prototype.
So I think from our perspective, the interesting part is what we have marked here with OMiLAB in the middle, namely what is the representation, what is the interaction that we look for. I showed you flowcharts here, that's just one example. But what is the model that we would like to use in order to describe that? We have this domain-specific modeling notion, so we would like to create models that are domain-specific and that also support then this kind of transformation. So that domain experts, a person who is an expert in healthcare, a person who is an expert in production can interact with that one. Maybe you have had this experience if you try to explain to somebody, create a model in BPMN, and you talk to a production engineer, the blue boxes, errors, what does that mean? And I think the interesting thing is how do we fill this box, what is the interaction behavior? We use flowcharts here on purpose since we don't know what is the domain language that would be interesting, and this is also a part of this development, of course. What is the language that we require for that? I can show you a different example that is closer to production, I believe. We have done the same logic in a different language, and what we see here, that's Petrinets. I think you have heard about Petrinets before, right? So we can do the same things with the same interfaces, with the same digital twin of the physical space with a different language as well. And now you can start to replace the languages, the modeling tool with those aspects as well. But it's a decomposition exercise that happens. Other questions, recommendations, inputs? I saved the car for the last step because there's a good likelihood that the battery will survive until then. But we can trigger it now and we can explain that as well. So this would be the case if you think about how do we move things into the warehouse. We said we do a drone, we would need to replace the drone by an autonomous vehicle. And we can run this now as well in here. So I have the same logic. We have again the interface is ready, the digital twin is there, and I will send our car from the grok to the It's a lab work, correct. But it should at least move, right? So we can recognize it works. It should move along the line now and get the way from our home position, pick something up and move it back to the home position. I get a message in here now, so the model stops the execution. Stop finishing, yes, we have stopped the loading process, and the car should move on and returns then with the goods. And now we can start to think about scenarios like how do we handle the loading process. Maybe we would like to load something on while we stop, so we have a coordination issue. We need to coordinate two different elements, and how can we resolve that one in a novel way? And all these things, second stop. So this stop should not be used, where it jumps over and we return back home. But again, the whole things that we can show here on this level can be done through models and through the interaction. We can of course simulate it as well, we can query the models, we can do all the things that we can run on conceptual models. I will stop the demonstration here. There's one output that Julia produced for CoDEMO already. Maybe you let me introduce that one. But we turn it around. Let's turn that around. So we squeeze the people into the room and they are all up anyways. Let's move it over there.
Yeah. Do you go first?
Yep, I go first. We move it on the corner.
Is like the first one here represents the OMiLAB network of nodes. Like we mentioned, we are 20 nodes in 9 countries and 2 continents. We have most of them in Europe and one in South Korea in Chongbuk. And here are the OMiLAB nodes leaders represented, so to say. And then we zoomed in on this one and we created the poster specific for the CoDEMO project, which highlights which are the nodes that are part of the project. They are in red, as they are also on the big poster, including the 3 associated partners. And then we have in not red yet. They will be transformed in red when the OMiLAB nodes will be built at the 2 partners in Valencia and Bielefeld, hopefully. And then in green here we have all the other partners, just to show which is the closest node that you can have access to and then collaborate and then bring your expertise in for all of these sorts of demonstrations. Of course, we are an open network. We can all collaborate with each other. It's not a restriction of country-based. And of course, you know, we are all all the time continuously developing and growing the network. Also, it's important to mention that each of these nodes has their own focus and expertise. So we have here in France, it's on industrial business transformation. I think the colleagues from Bergamo, they are more on the service engineering, if I'm not mistaken. Also, we have Arek here from Poland. It's on operations, management, and innovation. So as you can see, everyone has their own focus. Yeah.
You can compare pictures now and look at the actual people and find out what time has done to them.
Yeah.
All right. Thank you very much. Thank you for your time. Are there any questions? Is there any comments?
Yeah, I'd like to add something. I'd like to say why it's important to have these physical devices cheap and not fixed with functionality. Okay, that's something very important. We produce these MBOTs and everything with the students. We talk about 200, 250 euros for an MBOT because we buy everything and we put it together. And some people, they could understood because for the industry you came with finished physical products. But I think in the future it's good for our students to have the ability to extend the functionality of the physical products, like a robot arm. I can give you an example. If I have this and with the functionality, the existing functionality I have here, then I have to take care about the topology of the objects. Okay? Because I have to define where is bread, where is cheese, and so on and so on. Now, one of the student project is that we put also here a camera with neural networks, and I have the ability to test all of them and to throw to the field, and the robot arm will recognize what I have to pick up when. Therefore, I think this digitalization, we have to give to our students both capabilities. In the front for this innovation, but also in the back, in the physical objects, to have the ability to exercise that. That is what I like to add, Wilfried, because I think it's very important that the front, the innovation in the front requires capabilities of the physical objects. And if we like to have good environments for exercise for our students, then we have to give them the ability. For example, I can give them the ability here, and I can say to you some examples. If you have the same process with Wilfried, and this MBOT runs twice, then the next time we will not get 90 degrees turn off. You know, if you exercise that with the students, you take 2 times 90 degrees, and then you can 75, 60, 40, because you recognize the batteries has to be 1 volt. And by moving 3 times, that's not the case.
0.7.
Now, the students has to exercise. May I go up and put in the batteries for, say, via VLAN or whatever, something very, very new and sophisticated, yes or not? And that is also for the questions for the people who are more interested in the engineering part. You know, they recognize you have that, and then you cannot say to the field every time, charge batteries, charge batteries, charge batteries. No, they have to take care, not only about the compliance issues, which on this level, but also in the engineering, down there, not to see. That is something which I'd like to ask you, put a lot more effort, because I think in the future, we have also to give requirements to the products, not only to the innovation with the front. The front innovation needs product support. Thank you very much. Yeah.
Okay, and one question just before, I wanted also to add that Dimitris is a bit the father of all these initiatives, modeling technologies, and also the OMiLAB network. So,
It's okay, thank you.
yes, I think there is one question.
If you want to introduce the human factor, don't you think it would be useful to have a persona, or also to have a model of the human factor? Because
Yes, sure.
here, what you modelize is a process,
Yeah. Yeah, we can show you something which we think, because we believe in what are you saying before. In this, you will see that the transparency, this community of practice. We believe that we have to have this human issue which you mentioned, but not in this strict organizational science, but free. Therefore, we put this community of practice. We have papers. You can see that we believe that each of the nodes has to be totally free. Free for thinking, free for asking, free. And they work together because they have a common understanding. Therefore, if there's a human that is around here, that is our human approach.
And I may say that based on our previous experience, without the human factor, this network
Never.
isn't extended like this.
Okay, but for the scientific community, we are not sociologists. We choose this approach because they have 10 rules that set up the community of practice, and that's the more freedom rules which I never have found. You know, that is, they say let the groups work autonomously and don't give in nothing as a frame to press them, and let them think. Therefore, that is why we choose that, the approach.
Are there any other remark, question? No? Well, you're the perfect consortium because it's just time to go and eat. So what we are going to